This is Pegasus Launch Control at T-minus 33 minutes and counting, and I have joining with me right now Dr. Gary Rotman, the Mission Principal Investigator for the Laboratory of Atmospheric and Space Physics from the University of Colorado in Boulder. Dr. Rotman, thanks for joining us.
Thank you. It's a pleasure being here this morning. It's real exciting.
Well, I know that SOURCE is a little bit different than our traditional NASA missions, and this has been a team effort between the University of Colorado and NASA. Tell me a little bit about that partnership.
Well, this is a PI mode, Principal Investigator mode, and this is through a proposal we put into NASA. NASA funds us to do this, but we manage it entirely from the laboratory at the University of Colorado. We've selected an industrial partner, Orbital Space Corporation, and they are doing two things. They're providing the spacecraft for us, but they're also providing this Pegasus launch today.
And again, the SOURCE spacecraft arrived at the Kennedy Space Center on October the 26th of last year, and it was moved into our multi-purpose payload processing facility to begin its final processing. The protective covering was taken off SOURCE. Again, SOURCE will improve our understanding of how and why the variabilities occur at the sun and how these variable radiances affect our atmosphere and our climate. And then on December the 17th, the Orbital Sciences L-1011 aircraft arrived at the Cape Canaveral Air Force Station. And beneath it is the SOURCE's vehicle, the Pegasus XL rocket. The Pegasus was moved to the multi-purpose payload facility and put into a high bay to undergo testing and verification. And it also underwent 3 separate flight simulations prior to our launch today. And back in January, or earlier this month, SOURCE was mated to the Pegasus, and the fairing was placed around the spacecraft on January the 15th. And then on January the 22nd, the Pegasus with the SOURCE spacecraft was rolled out of the multi-purpose payload facility to the Cape Canaveral Air Force Station skid strip. The question then is, how does SOURCE complement the other satellites that we already have on orbit that are studying the sun?
Well, it's not only the ones studying the sun, but also the ones that study the Earth system. Aqua, the spacecraft that was launched earlier in 2002 to study the ocean system. Terra, launched back in '99. There's instruments on their Ceres which measure the amount of radiation coming back, all part of the radiative balance. All of these require and use the measurements that the SOURCE makes of the sun. Especially important will be next year when EOS launches the chemistry mission, or AURA, the mission to study our Earth's atmosphere, and especially the ultraviolet measurements that we make will be very, very important to that.
Terrific. And I understand that we have an animated tape that displays exactly what SOURCE is going to be doing on orbit. Could you talk us through that as we show that tape right now?
Let's go ahead and take a look at it. So this shows the radiation from the sun coming into the Earth system. It, of course, warms the atmosphere, warms the ocean, sets in place the currents, the winds. A portion of the radiation, roughly 30%, is reflected back into space. But the other 20% is either absorbed in the atmosphere, and then finally 50% down at the Earth's surface. And of course, it's very dependent upon the wavelength or color of the radiation, depends upon what level in the atmosphere or at the surface the radiation is absorbed. So we measure both the total radiation as well as all of the colors, not only measuring them, but measuring their variability for the 5-year mission.
And we are back live now with the L-1011 at the runway. We are broadcasting today from the Mission Director Center at Cape Canaveral Air Force Station. All managers for NASA, as well as the Orbital Sciences Corporation, are in place for the deployment of this vehicle today. And we have wheels up.
LC, LPO, we're wheels up. Copy, wheels up. Takeoff time recorded 1917:00 UTC.
And we are right on time. This camera view from the belly of the L-1011 as the landing gear are tucked inside. You're looking at the nose of the Pegasus aircraft with the skid strip and Cape Canaveral Air Force Station falling away beneath it.
I'd like to perform step 39. Launch team ready for transient power and final launch readiness poll. RCO.
RCO is go.
RCO is go. Peg.
Peg is go.
Peg is go. Orbital.
Orbital is go.
Orbital is go. NLM.
Source, NASA, and the University of Colorado launch team are go for launch.
NLM is go. Launch team is go to proceed with final checklist at L-4. Check step 39 complete. Drop on my mark. 3, 2, 1, drop.
And Pegasus is away.
Pegasus away. This is Peg on the countdown net. We see arm of all 5 safe and arm. Stage 1 ignition.
Arms are arms. Stage 1 ignition.
Attitude is nominal.
Attitude nominal.
AGCs are nominal during the stage 1 burn. This is Peg. We are 14 seconds in the stage 1 burn of the Pegasus source vehicle today. Attitude remains nominal.
Attitude nominal.
All power buses remain strong. FTS is nominal. We see solid AGCs on our command destruct receivers. Attitude remains nominal during stage 1 burn.
Nominal.
Our 32 seconds into today's launch. Attitude remains nominal. We have maximum dynamic pressure. Attitude remains nominal. Attitude nominal between the 1-2 coast. All buses remain nominal. And we have indications of stage 1-2 SEP as well as the 4 interstage SEP switches. Stage 2 burn, and we have nominal attitude during the stage 2 burn of today's flight. We are 10 seconds. We have stage 2 SEP.
Stage 2 SEP.
Stage 3 ignition at 461. Attitude is nominal, and we have indications of
Stage 3 ignition.
Stage 3 ignition. Attitude remains nominal during stage 3 ignition. Vehicle increasing its pitch angle slightly. It's continuing to gather velocity and increase in altitude. Altitude is nominal. Power buses remain strong. And we see the load shedding after separating stage 1 and 2.
Performance remains nominal.
Altitude is nominal. FTS system is separated with stage 2. Attitude is nominal.
Attitude remains nominal.
Altitude is nominal. Stage 3 burnout is predicted at 5:30. Sequencer 5:30, approximately 20 seconds from now.
Burnout in 20 seconds. Power bus is strong.
The avionics and transient power buses continue to perform nominally as the vehicle is passing 6.5 kilometers per second. And we're seeing stage 3 tail off. Altitude is nominal. Stage 3 burnout, and Pegasus is in orbit.
Pegasus is in orbit.
Pegasus will now start a reorientation maneuver to orient the spacecraft in the negative velocity vector before separation.
Reorienting for spacecraft separation.
The reorienting maneuver takes about 60 seconds, and then the vehicle will wait another 60 seconds before separating the spacecraft to make sure we don't have any contamination from stage 3 motor chuffing. Attitude remains nominal. The vehicle is slewing around to the negative x-axis, negative velocity axis.
Power bus looks strong. Spacecraft telemetry.
Spacecraft continues to have nominal telemetry through the Pegasus stream. And we have, the vehicle has stopped rotating and is in the correct negative velocity vector for payload SEP. Payload separation expected at 6:50. Sequencer.
Spacecraft separation attitude has been acquired.
50 seconds from now. Transient bus remains nominal and ready for payload SEP. All buses remain nominal for today's test, today's launch. Attitude remains nominal. Bus is strong. we are 16 seconds to payload SEP.
Approximately
Attitude nominal.
Spacecraft separation.
The avionics and transient buses are performing nominally, and the vehicle is in the right orientation for payload separation. Let's see final adjustments, and we have indications of both primary and auxiliary payload separation. And the Pegasus vehicle is now reorienting to be orthogonal to the separating spacecraft. Power buses remain strong. The Pegasus vehicle will lose telemetry at sequencer 706 when the flight computer commands the transmitters off. The cam maneuver is complete.